Dear students, I am Angad Naik, Assistant Professor, Department of Mechanical Engineering, SGBIT, Belagavi. I welcome you all to session 6 of Module 5 on spur gears and gear trains. In this session 6, we will discuss about interference in involute gears. The reason behind writing interference in involute gear is interference occurs only in involute gear. We will try to discuss this with the help of a figure. In the figure, one can find there is outermost circle called as the addendum circle, which is the periphery of the teeth of the pinion or the wheel. Next to that there is pitch circle, this circle, then there is base circle, and at the bottommost part you find addendum circle. The vertical height of the teeth between base circle and addendum circle is the non-involute profile. For constant velocity ratio, the profile of both meeting gears should be tangent all time. In above figure, we can observe that the profile of the teeth below base circle, profile of the teeth below base circle, this is the profile of the teeth below base circle, is not involute. So when tip of one teeth comes in contact with the surface below the base circle of other meeting teeth, their undercut of teeth will occur below base circle. The same can be visualized with a different figure when we start the derivation. Now, where does this interference occur? It is generally found that interference occurs on flank of driver during approach. Now, how to avoid the interference? To avoid interference, normally undercut is provided below the base circle of gear. This we have already seen in the previous slide. Now we'll try to see the figure. A pinion with O1 as the center is meshing with wheel which is having center O2. Also, MN is the common tangent to the base circle of wheel and pinion. In the same line, KL is the path of contact between the two meeting teeth. Also, a little consideration will show that if radius of addendum circle of pinion is this, addendum circle is this. If the radius of the addendum circle of pinion is increased to O1N, so it is increased to O1N, the point of contact in the beginning it is at point L when addendum circle pinion is this. Now if it is increased to O1N, then the point of contact L will move to point N. When this radius is further increased, the point of contact L will be on inside of base circle of wheel and not on involute profile of the tooth of the wheel. So it will try to dig out material from the base circle or below the base circle of the wheel. So we can conclude that the tip of tooth on pinion will then undercut the tooth of the wheel at root. So at the root, and remove part of the involute profile of the tooth on the wheel. This effect is known as interference and occurs when the teeth are being cut. Similarly, if the radius of the addendum circle of the wheel is this, if the addendum circle, this is the addendum circle, if the addendum circle of the wheel increases beyond O2m, so O2 is here, m is here, so if it is increased beyond O2m, then the tip of the tooth on wheel will cause interference with the tooth on pinion. The points M and N are called interference points. So this point M and point N are called as interference points. Obviously, interference may be avoided if the path of contact does not extend beyond these interference points. So the limiting value of the radius of addendum circle of the pinion is O1n, and that of the wheel is O2m. So these are the outermost conditions, the boundary conditions. From the above discussion, we can conclude that the interference may only be avoided if the point of contact between the two teeth is always on the involute profile of both the teeth. In other words, interference may only be prevented if the addendum circle of two mating gears cut the common tangent to the base circle between the point of tangency. So, between the point of tangency. When interference is just avoided, the maximum length of the path of contact is Mn. When the maximum addendum circle for pinion and wheel passes through the point of tangency N and M respectively, as shown in figure. Now, how to avoid interference? In order to avoid interference, the following methods can be used. First one is height of the teeth may be reduced. Second one, the radial flank of the pinion may be cut back, known as undercut or undercutting. Center distance may be increased, it leads to increase in pressure angle. The last one is by tooth correction, that is the pitch, pressure angle, center distance and base circle remain unchanged, but tooth thickness of the gear becomes greater than p by 2 and pinion becomes less than p by 2. I hope you have understood what is interference. This is all for this session. Thank you.